Started.
Yeah. So, whatever. Okay. Cool. So basically the first session of translator, we covered the document translation flow, right? The doc translation flow. Basically doc translation, and then we also did TMX and UTM, correct? If I'm not wrong. So these are the things that we covered in the last session. So just to kind of do a recap, so doc translation is mostly async. Okay, so I mean, it of course happens through workflow as a part of the pipeline. So you have to define a workflow, and then translator is added as a one of the modules in that pipeline. And then tokenizer pushes the tokenized sentences to translator. Translator reads that JSON, picks all the sentences, then creates batches of sentences, sends it to NMT, gets the translation back, and on those batches, once the batches are translated, it applies TMX and UTM if applicable, and then creates an entry into the content handler. So when it goes to the content handler, although a batch of sentence or the whole JSON is sent, content handler kind of does a parsing on that JSON, breaks it into sentences, and then inserts into the DB. Why does it do it? Simply because it's more efficient, right? So the more you decouple, it becomes easy for you to read and write, right? So in order to make it read and write optimized, we break it into sentences and then store. Whenever you want to search, you can aggregate those sentences and return. Whenever you want to make an update, you can just directly go and update one row. You don't have to update like a huge JSON, right? So that is the reason why content handler stores it that way. So that is with respect to the document translation. Is everything clear on that front? Did you guys have any thoughts, any questions on document translation? Nothing, right? Cool. So okay. So next is there are two more things. One is block translation. Okay. And another one is sentence translation. Okay. So both of them. So in terms of both block and sentence translation, first thing to notice, both of them are sync flows. Both of them are driven by the, so you don't have any asynchronous or anything. So essentially translates a paragraph. Now why do we call it as block merger? As a block of text. So since block merger treats it as a we also call it we are actually translating. So then I think it doesn't
Only for us.
Past 4 days.
I think it's because of it's a check. No? Anyway, cool. So the thing is both flows. So block translation okay. Kind of related to that. But why do we call it block? Because terms it as block. So you know the structure, right? So the structure of block merger. We have a page, right? A page has a block and a block has a sentence. This is how the block structure is. Now, of course, there's a document is broken into pages are broken into blocks are broken into sentences. These sentences come from tokenization. This comes from block merger. Essentially, all of this block merger, the block merger creates that, right? So now we have already spoken about the doc translation, right? Which inherently also speaks about page translation because there is no page translation without a doc translation, right? Logically speaking. So now only two things that are left out is doc and sentence. This is the logic. So we have translated that doc includes page, sentence, because translation is at the sentence level. So one flow that is entire document translation flow. But separately, apart from a document, you can also translate a block, you can also translate a sentence. That is the logic. Okay. So now, in order to achieve that, okay. So in order to achieve that, what we do is, okay. So document is huge. So it is correct. Hold on. ಏನು ಕೇಳ
Because yours will be recorded if you use Linux.
Yeah, but I have a LAN port, MacBook adapter for I can't connect directly. Cut cut.
Full cut ಕೇಳಿಸ್ತಿಲ್ಲ.
I think the same.
ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ ನಿಮ್ದು.
Hello. That's good. Same only. Same only is difference. I mean, I have not connected to anything.
You unmute it. Okay, you have to be recorded. If I unmute mine, no, so some disturbance network issue. Lag.
Okay, then you unmuted. Okay, so okay, cool. Yeah, so basically what I was saying is with respect to, okay, we have done a doc translation, so which includes all of that. Now, page is not separately translated in our use case at all. We only translate block and sentence separately. Now, document is a huge document, right? It can be a document of 1 page or it can be a document of 10,000 pages also. So it goes async and these two are sync because block is a single paragraph, sentence is a single sentence. So now how is block different from a paragraph translation? So when you send a paragraph, the flow is very simple. You have a paragraph, you send it to tokenizer, tokenizer tokenizes it, then you go to translator. Translator has multiple sentences of that paragraph, translates it, and you give it back, right? So that's a simple paragraph translation. But when it comes to block, a block is always attached to a doc. That is very important, okay? A block cannot exist without a document, right? Because when you translate a block, you are actually going inside the document. So what in real life scenario, what happens? Your document is translated. Now you are actually validating your translations, right? You're going sentence by sentence and saying, okay, whether this is translated or not, whether this is right, what is the blue score and all of that. So when you're doing that, that is when block translation come into place. Like for example, you see a sentence and you notice that this sentence is not properly translated, right? In that case, what you do? Okay, before even translation, you notice that this particular sentence is unevenly split. Like for example, we had a paragraph which had 3 sentences, but when block merger actually, or when tokenizer actually tokenized that paragraph into sentences, it only gave out 2 sentences. Now the split is wrong, right? It's illogical. So now you want to combine them because you see that the split is wrong, or you see that a split should have happened at a point where the split did not happen. Now it's translated as a, I mean, although there are 2 sentences, it is being translated or considered as a single sentence. So even in such cases, you realize that the block translation, or basically that particular block or paragraph in rudimentary terms, has gone wrong. Either the split or merge or translation, anything of that has gone wrong. That is when you actually trigger a block translation, right? So now, so the context is this: you have already translated a document. You are trying to verify the translation of the document. Sorry, sentence translations of the document, and then you realize that the paragraph has not been translated properly. So that is when you go for block translation. So what does it mean? A block always is attached to a doc, right? Which means block will have a block ID, correct? It will have a block ID. It will also have a record ID, correct? Because a record without a record ID, a block ID cannot exist in this place. Now that is why, that is the difference between paragraph and block. So when you have a paragraph, you tokenize it and you respond back. But when you have a block, you not only tokenize it, translate it, but you should actually go and update the document again, correct? So in a normal paragraph translation, okay, in a normal paragraph translation, you have tokenizer and then you have translator. But when it comes to block, you have tokenizer, you have translator, and you have CH. Because you have to go and update it back to the document saying that this block was changed. That is what makes block translation a bit more complicated, because now you're trying to update the block itself. Now again, there are edge cases related to that, right? Because uh, uh,
in short, before we go ahead, this block translation gets called when a user tries to figure out that something went wrong and corrects it in content handler.
In the validation page, in the validation page of the translation. So when your split and merge, right, is block translation essentially. Okay. So there is another translation also in terms of block, where, for example, when you actually change the source sentence itself, when you change the source sentence itself, at that time, okay, when block translation happens, what happens? Your source and target both change. when you change the, so basically we have this S0 TGT and S1 TGT, right? So S0 TGT is the actual sentence. Now, what if the source sentence itself changed? So at that time, we create another key called as STGT, or basically S1 SRC or something like that. There is S0 SRC and then there is S1 SRC or another key. I don't remember the exact key name, but yeah, there is another key which actually keeps track of these changes. So S0 SRC is the original SRC of the document. Then when you have another SRC key, which actually says, because source translation, source can be changed multiple times, right? Now you are in a validation page, you go, now you split it, okay? Then you realize, no, it had to be merged. So you merged it. So this SRC keeps on changing, which means the TGT keeps on changing. So because of that, we have these two keys, S0 SRC, SRC, S0 TGT, and TGT. SRC, TGT keep on changing. S0 SRC, S0 TGT don't change. They are the original SRC and the TGT of the document. Okay. That is just to keep track. That's how, because you also got to know the blue score, right? Say, for example, you need something to compare. No, you need to know, okay, what is the actual translation and what is the changed translation, right? So because of all of that analysis type of post processing, you need those keys. So those keys are already there. Okay. So yeah, so that is with respect to the block structure. So now when you have this block, you have this block ID. So now let's say you did a split or you did a merge. What happened? The block ID is still the same, but the structure changed, right? Now the sentences are different. Now the content is different. So it again goes to tokenizer. Tokenizer tokenizes it, especially when you merged it. Okay. So there is a tokenization done. Once the tokenization done, you have your sentences and then what you do? You translate those sentences, go to content handler and update it. Now there is a use case. Let's say you have a block B1, okay, which is a combination of 4 sentences. It is a combination of S1, S3, S2, S3, and S4. What you essentially did is you merged both of these only in your flow. You merged both of these, call it new S1, call it S1 dash, S3, and S4. Now this is the case. You know what happened now? There was a block which had 4 sentences. You merged S1 and S2, created an S1 dash. And then you have S3, S4 as it is. There is no change at all. This was B1. When you did a merge, you changed it to a state B1 dash, where this is the new state of that block now. Now this goes for translation. So now you realize, now see, you have sent the entire block. So the entire block gets tokenized, the entire block gets translated, the entire block goes to CH. But instead of that, what if you had a way to tell that only this part was changed? S3 and S4 were not even changed at all. So why do you have to tokenize and translate? That's why you have another key called as modified sentences. Okay.
That's the one available in Workflow Manager.
It's in Translator, but you pass it as an API. So that I'll come to it. Okay. So you have this modified sentences, which actually says that in a given block, these are the sentences modified. So just go and update translations of only these sentences, not all sentences, so that these are just remain, they remain as it is. No SRC change, no TGT change. Here, S0 SRC, S0 TGT will remain as it is, whereas SRC TGT will change. Okay. Once you go through the code, it will be clear to you. I'm just explaining how that block translation works. So you go and then you get this translated. Cool. Is this clear how block translation works? And then you go update it back to CH. The flow is again the same. You trigger a workflow. Block translation has a workflow. So that is a sync workflow. So you execute that workflow. Workflow knows that it should go to tokenizer. Tokenizer has exposed an API. Translator has exposed an API. Okay. So these APIs are there. So you go to tokenizer, you get it tokenized. The block data gets tokenized. Then that output goes to translator again via the API. Again, then from the translator to CH, again the connection is via the API itself. So you write an API, you call an API, and the content handler goes and stores the data. Okay.
So these two are sync APIs, TOK and the TN. Translator.
Workflow to TOK is sync.
Sync.
Workflow to TR is sync. Workflow to CH is sync.
That is not sync. That's done by internally, no?
No. It's not done internally. That's the thing. See, as I said, right? Anything that goes via the workflow manager is always stateless. I told you the first session, right? Let's say you have async, right? And then you have sync. In both the flows, you have tool T1, tool T2, and tool T3. These will never communicate amongst themselves. They will always communicate via the workflow manager only. Similarly, come to sync, you have T1, you have T2, and you have T3. These will never communicate via themselves. They will always communicate via workflow manager, which means workflow manager calls tokenizer, gets the output, calls translator, gets the output. The difference is only here. Translator will directly talk to CH. The same goes with there also. Even in async flow, I again told you, right? This whole system, translator, NMT, and CH. So these will form one translation engine pipeline. So these are again, it's like how we have block merger, right? A microservice ecosystem within a microservice architecture. Similarly, this is a small microservice ecosystem within our microservice architecture. These two will perform translation. This guy will save the translations. But to the workflow manager, they act as one service, right? Similarly, this is an API call amongst themselves. But when it comes to this and this, it is via the workflow manager. Is that clear? Content handler. So content handler is a service which actually stores all translations. Okay, all the translations are stored here once the whole process gets over. Okay, so CH is kind of optimized to store and retrieve translations, whichever is here in the pipeline. Okay. Okay. Cool. Okay, so this is the block translation and this is the flow. There are APIs. I will show what APIs are. I mean, what APIs do we have? Then we have sentence translation, right? Sentence translation, as the name suggests, it is basically translation of sentences. So you pass a sentence to the workflow manager API. The workflow manager goes to translator, gets the sentence translated and returns back. Now there are two options here. One is an interactive translation where you give suggestions back saying for this phrase or this sentence, these are the possible translations existing. Or you normally return a translation saying this is your sentence, this is your TGT. So both are there. One is an interactive translate API, one is a sentence translation API. Okay. One is called interactive translate, another one is sentence translate. Both of them go via the translator. So now see, translator has to expose a block translation API. It has to expose an interactive translate and sentence translation API. Again, one for workflow, one without workflow. One for workflow and one without workflow. Okay. So these are the APIs which translator has exposed. So what we do, interactive translation is again, so here translator acts as a wrapper over NMT again, like in all cases, document, block, sentence, it's always a wrapper. So if translator has an interactive translate API, it means that NMT also has an interactive translate API, right? Similarly, it happens in sentence translation as well. Okay, we pass a sentence and we get the sentences back. Of course, this is a bulk API. Even this is a bulk API, as in you can send multiple blocks in a single block translation flow. Even in sentence, you can send like a bunch of sentences. Okay, that is with respect to the translation. Now, just not a digress, but yeah. Since workflow manager supports these, right? So workflow manager has sync and async. Now, in terms of sync, the contract keeps on changing. As in, if you are triggering a translation workflow, like the one that I have in block translation, the body changes. If you're triggering a sentence translation flow, the body changes because the body now has sentences, not blocks. That's why the workflow manager contract is an agnostic contract. As in, it's a JSON which takes the, it kind of accepts the, or it acts as like it acts like a facade. Okay. So if the workflow belongs to translation, then it will accept the body that is required by that workflow. Okay. If you have async, it's constant. Like you send files, you get the translation back. But when it comes to sync, block translation has its own body, sentence translation has its own body. So block translation has its own API contract, sentence translation has its own API contract. But what is a wrapper to both of these? Workflow manager. So workflow manager does not have two APIs, right? It has just one API, that is sync. So it takes the body of these APIs. If you are calling up, because what does workflow manager essentially do here? Take the input from the client, pass it through all the services and get the output back. So for that reason, whatever block translation is exposed as a contract will be taken by workflow manager. Whatever sentence translation exposes as the body of the API will be taken by workflow manager. Got it? That's why you saw modified sentence in workflow manager, because modified sentence is a part of this guy. And that's why even you can send tomorrow you can send 100 other things. Workflow manager will still accept it because workflow manager knows that the module in the background will accept this. Got it? That's why in workflow manager you will have workflow code related configurations as well. As in,
now I'm able to understand those sync workflows,
yeah,
which are limited only for these flows.
So we have only two sync workflows. One is block and another one is sentence, another one is download, but that's a very specific use case, so you don't have to use a lot. So we have just two types of sync workflows, because of which you have two validations, one for sentence and one for block. That's why now what you can do is, you don't have to hard code your workflow code. You don't have to say if it is FC, BM, TK, TR, this is how the validation is. If it is say FC, TK, TR, this is how the validation is based on workflow code. All you have to say is the workflow that is being executed right now. If it has this tool, then this should be the input. Say for example, if it is OCR, OCR takes a config object in the body, right? So in the configuration, in the validation, it would say if the workflow that is being executed right now has OCR as a part of its, if OCR is one of the steps, then config is compulsory in the request. That's how in the validation layer you have multiple validations.
Yeah, Tesseract,
OCR, Google Vision, that is tools based, because tools are still configurable, right? We are not hard coding workflow code. We are just saying if this is the tool, then this is how the validation should be. Is that clear? So that the modified sentence comes from there in workflow manager. Okay, so yeah, so interactive translation and sentence translate. So now there is another API. Okay, so one is with workflow and one is without workflow, right? Now this API is also there in Translator to give you like a plain translation API. Say for example, if anyone wants to use Anuvaad for translation purposes, sentence translation purposes, no doc, no block, nothing. Sentence and that too very generic sentences, nothing related to legal and all of that. In that case, we wanted to expose a very lightweight API which takes an SRC in input and gives a TGT back. There is nothing inward, no TMX, no UTM, no caching, this and that, nothing. It just takes SRC as an input and gives the TGT back. So that's a very simple API, which is sentence translations without workflow API. That also is there. Okay. What is the input? SRC is the input. What is the output? TGT is the output. Of course, I mean, you need to pass the language also. You need to say that this is the source and I want this target, all that. So you have source target, you have SRC, and you'll get the TGT back with respect to that. Okay, so that is the without workflow API. So interactive translate, I'm not sure if we have a without workflow API, but just check it out. Maybe it's there. Now, why? Why are we doing it? Why are we not moving via workflow manager, right? Technically speaking, anything in the system, any workflow that happens should always happen via the workflow manager, correct? But now we are doing it without workflow manager because one of our basic principles is that every tool, every module in the pipeline should also act as a standalone system, not just a part of the workflow. So every module has two avatars, right? One is inside the pipeline as a tool in the workflow and a standalone machine. So here, Translator acts as a standalone machine in this particular use case. Okay. So one more reason for that is if you include workflow manager, then you have another hop, right? So you have this. So you have to now consider this network latency as well. Now it becomes slower, right? So we just wanted to decrease that hop to make sure that as fast as we can produce it. So that is one API without workflow when it comes to sentence translation. Now one more thing with respect to models. Okay. Now what happens is Anuvaad is an open source software, right? So since Anuvaad is an open source software, we want to make sure that we support multiple models. Say for example, we want to make sure that Anuvaad supports Indic Trans as well. Anuvaad supports some Google NMT translation as well. Right now, we just had our own NMT when we were developing this. But in future, we wanted to make sure that we support multiple models. Because of that, we opened a hook here in Translator to support multiple models. And we defined the contract saying any model that can be reached via Kafka or an API through Translator can be integrated. Let's say you're using a Google NMT and you want Anuvaad to use Google NMT. Let's say, for example, I'm a data scientist. I've designed my own model. I've trained my own model. It's a very comprehensive translation model, but I don't have these features. I don't have engineering with me for doc translation, block translation, sentence translation, TMX, UTM. I don't have any of that. But Anuvaad has it, right? Anuvaad has the digitization, OCR, all of that. So I will port whole of Anuvaad but I'll only change the model. I'll not use OpenNMT or IndicTrans, but I'll use my GNMT. In that case, Anuvaad should support. We should not say that we are not going to support it, right? Because of that, we opened up a hook in Translator, so that Translator can now support multiple models as well. It can support multiple models. Now, when I say multiple models, there are two things to it. One, supporting a model that is not either OpenNMT or IndicTrans. I mean, a model that is not a part of our ecosystem. That is first thing. Second thing is, it can also be a user-based model, right? Say Anuvaad can have 20 models live, but then can choose a model based on the user. Let's say if Shriyar is translating, we'll use M1. If Ratan is translating, we'll use M2. Even that is a possibility, right? Since in order to do this, we kind of created a support in Translator where multiple models could be live at a single time and a user-based model selection should be supported. First thing. Second thing is any model that is apart from NMT also should be supported. Now, what will happen, you think? Now, let's say I ported Anuvaad to another ecosystem, say Bangladesh. Now, Bangladesh has its own translation model. Now, I don't have to make any change in my code at all, right? I don't have to make any change. I can even port NMT. The only thing I have to do is disable that, enable this. In my models, NMT maintains a list of models, okay? So NMT maintains a list of configurations. In our NMT service, I'm not talking about the NMT model. NMT as a service maintains a list of models which are live. For say, let's say if it is English Hindi, model 142, if it is English Kannada, model 145, like that. Similarly, what I have to do is I have to just ask Bangladesh to keep their model alive, as in just set it up, get it up on a server, and then give us some credentials. Tell us, can we connect to you via Kafka pipeline? As in, can our Kafka queue extend to their server as well if it is a part of the cluster, or can we connect to you via API? Which is most of the cases. Most of the people will support via API, right? So if you can connect via API, then that model will be listed in our NMT as one of the active models for a given language pair or any language pair that we want, and then it will be used. Got it? So when translation happens, whether it is doc or block or sentence, that check is always done. But how is that check done? That check is done based on two things. One is the language pair, second is the user. If the user ID is this, and if this user is mapped to a model, then please use that model. And that model, whether if it is reachable by Kafka, use the Kafka way. If it is reachable by API, use the API way. If a user is not mapped to any model, or if the model that has been mapped to the user is inactive, then by default fall back to NMT. NMT is our OpenNMT or IndicTrans in the present case. Is that clear? So this is the fallback logic. You support multiple models, either communicating like this or this. So you either fork a producer or you create like a REST thread, and then you or if that doesn't work, then just fall back to NMT, which is an OpenNMT model. Okay, so Translator supports that as well. Is that clear? Yes. Okay. So block, sentence, and multiple UTM and TMX is UTM TMX is applicable here also. Same logic for block, same logic for sentence. Only if it is a plain sentence, then there is no TMX, right? Then there are certain configurations where you could say that I don't want these roles to translate. Say for example, there was a use case where we wanted some users to be, basically when they trigger a translation log, we didn't want them to, translate a document, but rather annotate it, right? For example, annotator has a role, right?
Yes.
Annotator is one such role, and no NMT is one such organization. Okay, this is an org and this is a role. Okay, so here what happens is when they trigger a translation, doc translation, everything happens, but only this part doesn't happen. Translator to NMT, NMT to translation does not happen. Whatever they send, it is just saved in content handler directly. This part is skipped and direct CH call is made, which means the document is accepted. It is broken, it is converted into JSON, pages, blocks, sentences, all have been generated. Tokenization is done. Only the translation part is skipped and it is saved as it. So what happens when that guy opens the translated on your validation screen, you will not see any translation. What does that mean? This guy is an annotator, which means he will start translating the sentences on his own. and he won't be able to, he won't get any translations. So he goes and he starts typing every translation. Every time he types a translation, he does save. So when you save, you again go to the sentence translation and just go and save it to content handler. Sorry, it directly goes to content handler, not sentence translation. Save sentence is an API exposed via the content handler. Okay. So he types a translation. There is no vetting of the translation. Because we kind of assume that this guy is already an expert, right? So whatever he translates is directly saved to the content handler.
So in this case, the purpose of annotator is only to have the translation done.
Data collection mode.
Yeah.
We want to collect data. We want to collect translations from them.
Okay, and that will be used for model building later on.
Etc. etc. Yes, that is the annotation. Similarly for annotator. So now what we wanted is, so instead, before we created an annotator role, we were not sure as to what should we call this as. Okay, we didn't know what is the actual term. Should it be annotator or should it be some other translation vet expert or something like that? We didn't know. So what we said is, for time being, let's create an organization called as NoNMT, and whoever belongs to NoNMT, let's take them to this flow. Got it? So if you are a NoNMT user in translating, this part is skipped and directly go to content. So all of these are configurations in Translator. This is why I wanted to make two parts of Translator, okay? So that though it becomes very clear as to how it works.
For NoNMT or the annotator role will work on. The translation won't happen.
Yeah, no translation, no TMX, no UTM, nothing.
If there is only annotator role for any other role, so translation will happen. Will happen, and the content and the split merge, they won't have access for that.
Yeah, so they can just do a rate and all that. Yeah, so that's the rating part. So NoNMT will not do any translation. With respect to annotator, you do a rating. So yeah, the whole point is we didn't know that annotator role could do this, so we created a NoNMT basket of users. So for which there is no translation. And yeah, so workflow, as I said, right, this workflow without API has no TMX and no UTM. Okay, both of them are blocked for these users through that API because, as I said, it's a lightweight API. Okay, that is one more thing. Is this clear? Okay, so let's do a code walkthrough. Okay, so code walkthrough was pending for this session, right?
Yes.
You can see my screen? Right, all right. Cool. So what you see now are the APIs. Okay, these are the APIs. Now we are forget about the doc translation async flow now. First, let's do block and sentence, and then I'll show the doc translation flow. So here you see the workflow doc translation, but this is a REST endpoint. This is just an endpoint that we created. It's never used, of course. We just created it for my personal testing and stuff like that. And if there's a very small document here, there's only a document of 1 page. That time you could use it, right? So that's why I just kept it as it is, if required in future. Then this is your block translation. Okay. So block translation is the one that does your translation of the block. Text translate is the translation flow, which does a plain translation, the one without workflow. Then you have sentences translation, right? This is a sentence translate with workflow API. TMX bulk, this is a TMX upload API. Okay, you take an XLS and you upload. TMX create is for TMX creation without XLS. Use a normal JSON. TMX delete is an API for deleting the TMX records from the database. Okay, it has its own contract. You have to pass the source phrase and the TGT phrase, and it gets deleted from all based on the access. Get all keys is an API is basically TMX search API. Okay, just change it to search. Okay, I don't know why I named it as get all keys, but yeah, just change it to TMX search. It's a search API. Suggested TMX create. This is API for suggestion box. Oh, by the way, I forgot to tell you about suggestion box. No. Yeah.
I know suggestion box. You need to explain.
Yeah, I'll explain it. Sorry. Let's go to that. I remembered. Okay, let's do suggestion box also. Okay, so what is suggestion box? Suggestion box is like another part of TMX. Okay, So what do you mean by suggestion box? So suggestion box is a use case. Oh, sorry. Sounds good. Okay, so suggestion box is a use case where, let's say, okay, so this is how it is, right? When a translator is translating, the TMX is applied at multiple levels. Either it is applied at an org level or it is applied at a user level. As in, a user could save his own personal TMX or an org could save his own TMX. So when the translation happens, TMX is applied, UTM applied, the story is fine. But sometimes what happens is while translating, so this is more like a user behavior type of thing. Okay, so this we found out through user behavior that when people are translating, they expect certain phrases to be in TMX which are not there. See, for example, if I am an organization and if you come to me saying, okay, we have this Anuvaad translation pipeline, it has TMX and everything, what would I do? When you explain to me TMX, the first thing, very intuitive, that I would do is just go copy paste a glossary from somewhere, take like a dictionary, a legal dictionary from one of the law websites, and then say, give it to you saying, this is my TMX. This is very intuition, right? Because they don't even know how translations work, what are commonly used phrases, what are mistranslated phrases, all of that. So when a system goes live in a given state, at that time, the TMX is not a very rich TMX. Of course, it might even have a lot of problems in it. That, of course, you have to clean and then upload. That is another story. But initially, it is not clean. So it goes on getting enriched as the time progresses, right? As more and more translations keep happening into the system. So now, as a part of this process, TMX upload can either go through an XLS upload or they can go through a JSON, like I say, a list of objects, and then you create. But what if a translator, while translating, figures it out or kind of has this idea saying, okay, maybe this should have gone into my org level TMX, right? Say again, like learned counsel, right? Vidvat Adhivakta. He sees that it is translated to Vidwan Adhivakta. But then he knows that, okay, Maharashtra High Court will always need it as Vidvat Adhivakta. So he can do a suggestion, right? He can actually suggest to the Maharashtra High Court saying, please consider adding it into TMX. Such requests will always go to suggestion box. Remember this. Ratan, is this clear? Yeah. Suggestion box is a suggestion from the user to the org level TMX. Now, what does that mean? If a user has sent a suggestion, then it has to go through an approval cycle.
And only the organization here can add the TMX level for
org level. Yes.
And user can add it for UTM.
Exactly.
In this case.
Not UTM, but user level. User level TMX and user level UTM, both. Okay. So an org only can add TMX at the org level. So now he sends a suggestion to the organization saying, please do it. Now, we know the role structure, right? In Anuvaad, the role hierarchy is this. You have super admin who will, basically there will be a set of admins who will report to a super admin, correct? And then there are translators who will report to our admins, correct? This is the role hierarchy. Is this clear? Yes. So this is at the high code level, this is at the user level, and this is at the system level. So whenever a suggestion goes from a translator, who does it go to? It goes to an admin. So the admin has to log into the system, go to his suggestion box or inbox of the suggestion box, and then say, I approve or reject this. If he approves the suggestion box, then it goes into the org level TMX of that particular org to which this admin belongs to. Got it? If he rejects it, then of course it gets rejected. In either cases, it gets deleted from the suggestion box database. So suggestion box is a drop box, is a drop box for suggestions. So there's no validation, this and that. Okay. So you say this is the SRC, this is the DGT. I think that they should go at the org level. He sends a suggestion, the admin will either approve it.
Where are these stored until the process of admin approval?
It's a separate Mongo DB. It's called as the suggestion box DB. Okay. So it's a separate Mongo store where the suggestions are stored. Okay. So it goes. So suggestion box create can be done by translator, can be looked up by admin and approved or rejected by admin. Once it is approved, it goes to the TMX store of that org level. That is the story. Okay.
So
like some more enhancements has to be made on this solution.
As in?
Currently, we are passing only sentence wise.
Hmm.
Admin doesn't know who has passed this particular phrases.
It's there, no, it's the DB has the data, it's not displayed on the screen. The DB clearly remembers who sent this.
So currently we are not passing through request. So this person is sending this particular data. We are only sending the sentence purpose.
No, we are sending sentence, we are also sending who is sending this. It's there. The suggestion box API does contain that, no? It does contain the user ID. How come, dude? Suggestion box must contain user ID. Create, sorry, validate. Suggestion box create ID, org ID. See, uploaded by. Uploaded by is there, no? Of course, see. Uploaded by, created on, updated on. These are all audit information. This will be there with every entity that we create. So that uploaded by is the ID of the user who is suggesting this. Got it? Yeah. So this just has to be displayed on the screen, but yeah, that's different. Okay. So this is the suggestion box, create, update and delete. Like if you want to, because once it is either approved or rejected, it has to be deleted also, right? So that deletion happens here. And then of course, this is the search API. And then your add headers, which is a very common API across all systems. Of course, adding, there will be keys added and removed, right? In DMU ecosystem, you don't have org ID, roles, all of that. So those are not there. But in the Anuvaad ecosystem, all of these are there. So
if we are supposed to delete any suggestions, it of course has to go through the org level authentication, like the role based.
No, you can delete your own suggestion. No, say for example, you suggested something by mistake. No, right? So you can delete that. Only approval goes through the admin approval side. Okay, so that is your controller. Let's go to block translation. First finish the sync flow and then we can come back to this. You do a block validation, see whether it is job ID, metadata, if they have text blocks, record ID. Why do they need record ID?
Each block has its own unique record ID to identify itself.
Yeah, because it has to finally go and get updated in content handler. Without record ID, that is not possible, right? So that is the reason. So these validations are there. Okay. I remember there was one. Okay, that is in workflow manager. Sorry. Okay, so basically this is the validation. Okay. Once this validation is done, error. Okay, now go to block translate. See here, as usual, you first create a task ID for any flow. Then you create a start time. And then that is the state. Translated is the state. Okay, now you start your block translation. Next. Yeah, so basically these are some initial keys. Then get sentences for translation. What does it do? It actually breaks that. So you take a block. Now that block has to be converted into sentences, right? Because you need sentences. So the tokenized sentences is already there. Remember, through translator, it has already come from tokenizer. We are in the translator system now. So we already have sentences for the updated block. So those sentences are picked, right? Those sentences are picked. And once those sentences are picked, of course, there is some logic with respect to save key. Okay, if the save key is true, which means it is not, I mean, basically, it's already saved. You don't have to do anything. Just don't translate it. Just keep it as it is. That is the mean. Okay. And then, yeah, you have SID and stuff like that. Just go. I'm not going into the root levels of logic. Okay, that I want you guys to understand because only then you will go through the code. That is the reason why I'm not telling all of that. Okay, so yeah, you have these keys and stuff. You get your sentences back. Once you get sentences back, now you have to translate them, right? So this is when you get the sentences back. Once you get the sentences back, you first get the NMT URL. Why do you need NMT URL? That is because of
individual models.
This. Based on the user, based on the logic, it might change, right? So you need to get the NMT URL. So you go to this function, see, you have your NMT in, you get the connection details, host, everything, because this is an API flow. So you need to look for host. If the host is an NA, then you fall back to NMT translation logic. Clear? Once you get your NMT data, now what you do? You said go to NMT, get the translation. So you make a call to NMT. See, API call to NMT, you get the NMT response. If the job belongs to no NMT, then you don't do anything. You just return the empty text, right? If you get the NMT response back, then validate the status. If state and everything is fine, then you create a translation input for content handler, right? So you create a content handler input, you make a call to content handler with the NMT response. You have the NMT response, and of course, these are some logic. Like for example, as I said, right, TMX and everything is applied, which is applied after translation. So before going to CH, you apply your TMX, UTM, everything.
But it's calculated prior to translation.
Yeah, that's what. TMX two parts: calculation, pre NMT, replacement, post NMT. Remember that. So, okay, so now you have it, as in you have already generated an input for CH. Once the input for CH is done, you make a call to CH. CH gives you a response. If it is successful, you just send back a success response saying the block has been translated successfully, which is your split line merge logic. Clear with respect to block?
So here there's a back and forth communication from content handler to the sync block translation and then connect back.
Connect back to the workflow manager saying we have received everything. Okay. Yeah, so cool. That is the block translation flow. Then you have a text translation flow. See, first you do a text translation validation input. Text list as in list of texts. SID, SRC, tagged prefix. Tagged prefix is basically how you want it to be translated. Tagged prefix is for interactive translation. Okay, it was expected by NMT, so we include it here also. But it's mainly required for interactive translation. Yeah, see, text translate calls the interactive translate API, as I said. Go to interactive translate or do everything same. Task ID, this, that, get your translation, first get stored hypothesis. Okay, you should know this. In interactive translation, UTM is heavily used. As in, let's say you have a, let's say this is Supreme Court of India. This is a sentence. Translation is ये भारत का उच्च न्यायालय है. This is already saved in UTM by the user. Okay, this is already saved. Now, after like around 5 to 6 months, in one of his documents, the same sentence comes again. What is the output? Hey, Bharat ka uch न्यायालय, because it is already stored in UTM. Now, what if he wants to change it? So what he does, he presses backspace, clears the entire translation and tries to type a new one. At that time, if he types a new one and saves it, the UTM is replaced with the new translation. Or what if he's looking for a translation? He just types ye bharat ka and then presses a tab or a space, which means he's looking for a suggestion. That is interactive translation. He's looking for a suggestion of the translation post this. As in this, he already knows this is his tagged prefix. He has already written the prefix. He's expecting post that. Uch Nyayalaya hai, ya Supreme Court of India or anything of that sort. All of them will come in suggestions. Now that suggestion is a union of UTM and NMT. If a user is already stored S1, S2, S3, S4, this is the source. T1, T2, T3, T4 is already stored. Whenever S1, this sentence is encountered, this TGT is returned by the system. How? Through UTM, because the user has already stored it. Now, this time, after 6 months when he's translating, he sees this, but he says, okay, I mean, T1, T2 is fine, but I would like a different value for T3 and T4. He's not happy with that. He wants to change. Now but he doesn't know what to do. So he's pressing a space, he's pressing the suggestion button. So here, for these two sentences, we give out multiple suggestions. We say, see, T3, T4 can be one, T5, T6 can be another one, T7, T8 can be another one, which means for this source, in order to translate this source with a prefix this, these are the possible suggestions. Remember, what are the parameters? Source and prefix, both. So these suggestions take two things into account: the source sentence that is being translated and the prefix that is already there. So based on this prefix, these are the three possible translations. Choose any one of them. Now, how do you get these? This is nothing but a union. This is a union between UTM, and then you create a union between NLT. Okay. So machine returns a few. UTM already has. So T1, T2, 3, T4 is already same, which is already returned by UTM. T5, T6, T7, T8 based on these parameters is returned by NLT. Got it? This is interactive translation where the system interacts with the user and gives them the translation. So this is that stuff. What do you mean by stored hypothesis? T3, T4 is the stored hypothesis, which is UTM. So yeah, you get it from content handler database. Okay. And then again, for interactive translation also you need a URL, body, data, everything. You get that. Once you get that, you make a call to NMT. If the status is successful, then you add. See, remember this. What we have done, chres.extend. When you do an extend in Python, when you already have a list and you want to add another list to it, so you do an extend. So what was the previous list? The response of ch, which is T3, T4, UTM response is already there. Whatever you got from NMT was T5, T6, T7, T8, which you have extended. Got it? Okay, so you have the task output, everything. Then there's a stored output. Then this is NMT interaction. And of course, deduplicate hypothesis, right? So basically, what if NMT also returns T3, T4, stored hypothesis also T3, T4? You need to do some deduplication. So that deduplication logic. Finally, you do your translate sentence and then you respond back. Got it? That is your interactive translation. Then you have sentence translation. Like how we have block, now we have sentence via the workflow. So that time again, perform your validation, go to translate sentences, everything is same. See, if you are keenly observing, the structure of the function are all same. Block, text, sentence. Only difference is one guy might call a stored hypothesis function, another guy might call a get translation function. That's all. So this is how you should also write as, because the moment you see, you should understand, okay, this is how the flow of logic is. Again, you get your sentences translated. Input, you'll have a model ID. Fetching a model. Why do you have to fetch model? User based, language based, user based, any model that is live, inactive, all of that. If there is no model, you have to do a fallback. If that also is not there, then you just throw an error. Okay, and then you fetch the translation using your NMT and you get the translations back. It's the same sentence translation. The structure is same. That's why I'm not going much into deep. I want you guys to go line by line and try to understand, because in the reverse KT, I would expect a line by line explanation of these functions. Okay. Okay, fetch batches and everything. Okay, so that is the straightforward logic. Now you have consumer. Consumer, come back to translator part 1 KT, doc translation. So first we have our translator consumer. Okay. So translator. Okay, so translator has 3 consumers in itself. Okay. So the translator has 3 consumers. So translator is one system, I mean one Flask application, like how our workflow manager is. 3 consumers. One is TMX consumer, another one is NMT consumer, and another one is translator consumer. 3 consumers inside the same application, like how workflow manager also had, right? It also had multiple consumers. What does TMX consumer do? TMX consumer is for your TMX upload. The moment you upload an XLS, we don't want it to run via the API, right? We want it to be pushed and then uploaded asynchronously. So that is one thing. Then there is NMT. NMT is the consumer which is listening to the NMT's output. Like once the sentences are sent, you need the translations back. So this consumer keeps on listening to NMT. Then there is translation. This is our workflow manager wala topic. This guy listens to workflow manager. This guy listens to NMT. This guy is an internal consumer. Got it? So let's go to TMX consumer. You have your TMX topic, right? You have push to TMX store, right? So basically you take the sentences, you put it onto the queue, basically making the TMX process asynchronous. That's all. Because XLS file can be huge, right? Even the list can be huge. Why to make user wait till then? So Kafka is used here. Then you have translator consumer, which is the consumer which listens to workflow manager, which takes from tokenizer, gives it to translator, the translation starts, all of that. Trans NMT consumer is a consumer between translator and NMT. Got it? And there's of course one producer. The same producer is used everywhere, right? So doesn't matter. And then yeah, these are the structure. This is how NMT input, NMT output are all there. This is just for my reference, like when I was coding. Okay. Then you have translator repository. Repository, I think it uses only my MongoDB. Where is Redis? Do
For
you see
TMX, it
Redis?
should be-
TMX is for Redis. Sorry, Redis is for TMX, not for normal translation. This is only Mongo. Okay, insert, update, search with multiple collections, because sometimes you need a translator collection, and I think you might need another collection as well. Trans batch collection. Okay, translator batch collection, and this is another one. You have another translator collection. So translator collection is where you store the data for translation, task ID, task, and all of that. Task batch is where you store the page information. Once you get the output, right? You get the output from NMT and you have to store this page, right? So that the cron job can pick it up and then make a call to CX. That is this. Okay, block translation service, I just showed you the logic. Text translation service, same, you get from NMT and all of that. In both sync flow, everything is same. Most of it is same. A translator, go to NMT, from NMT, come back, call to CH. After CH, go back to workflow manager. That is the flow. Only the structure changes. Sometimes you're receiving sentences, sometimes you're receiving a block. That's the only difference. Then you have TMX repository. Okay, this is our TMX service. Okay, TMX first push CSV to store, which means this is an XLS upload logic. Okay, we do our XLS upload, right? Then this is push TMX to store. TMX to store function is the function which is called when you send a list of JSON, right? When you send a list of object and you want it to be ingested, you use this function. Pay attention to this. This is where that logic lies, where the 0th row has to be headers, first row has to be empty, second row onwards is your data. This is how you should parse for your key value pairs. This is like a, I don't know, like a contract decision taken that, keep one row empty and then start from the second row. So we just followed it. No much brainstorming on that. Okay, and then this is push to TMX store. Now here you should pay attention to this part. So as I said, I mean, I've already explained this, but again, you pass SRC TGT as a TMX phrase, but while storing, you store multiple versions of it, right? 5 versions of it. One version is all source target, all caps, all small, and then what is that? Title case, camel case. There are multiple cases. Okay. Along with that, a reverse pair also is stored. So this is the reverse locale array, reverse locale, right? So first you take SRC TGT, pass it to a function, get all the flavors. So fetch different flavors of sentence. What are the different flavors? We'll just take a look at that also. Yeah, title case, small case, all caps. 3 versions are returned along with the original. So 4. Then there is another reverse locale, 5. So for a given phrase, 5 versions are stored inside the TMX store. And then you create, of course, I mean, if you want to do a bulk insert, all of that, just see, okay, try to optimize if you can. Push TMX metadata. Metadata is the metadata table for TMX. As in, once you insert a TMX into the TMX store, which is the Redis DB, you need to store a copy of it, right? A record of it saying this was the file name, these were the number of phrases sent into that file, and this was what was stored. So it's a audit or a metadata table, which is in parallel to the TMX table. Delete from TMX store is a logic where you want to delete from a TMX store. Okay. Based on org ID. So you send as SRC, we'll find out all the different versions that is available for that, and then we delete it. This is also an interesting logic. Okay. Delete from TMX. Please go through that. If you have any questions, I'll explain. Get TMX phrases is for the translation. So you pass your user ID, org ID, context, locale, you pass your sentence. You say which TMX level do you want? Do you want org or user? And then we return back. Yeah, first different flavors as it is. Then this is our hopping window logic. This is how the hopping window logic is. I want you guys to go through this and I want you guys to explain to me how does this algorithm work. Okay, I've already explained it, I think, during DMA glossary. But anyway, just go through once again and tell me how this works. Okay. So this is the guy which makes like millions of computations for a given document and all that. Get TMX with fallback if it is user level, org level, global level. So first preference is user, second is org, third is global. It's a fallback logic. Replace NMT with user TGT. this is alignment. Alignment, labse, phrases. Yeah. So either cosine index, all of that. So this is that function. So basically it takes TMX phrases, it takes the SRC, it takes the T. Why does it take TGT? Because here you have to replace, right? Once you get the output from the labse or attention API, you need to replace that phrase in the TGTs. That's why we send TGT. Otherwise, all you need is TMX phrase and SRC. You just have to pass these two things and you'll get the alignment back.
Currently, only labse is used. The laser is not used.
No. Only labse is used. That also comes from NMT, but that also we have disabled. These days we use the attention. So the attention API from NMT, right? We use that. Okay, so you have your TMX replacement logic. Cool. And then TMX without NMT phrases. I mean, this is just some audit information saying, okay, these were replaced, these were not replaced. How many of these are picked from the cache? Cache as in NMT TGT array. I told you, right? Do you have an SRC? You have a TGT. Once labse or an attention API says that this is the phrase matching this source, we store it in our DB. We create a memory of TMX on its own. TMX itself is a memory. Then there is a memory which backs TMX. So there is two multi-level cache. Okay. So this is that memory part. Here you have replaced with labse alignment. Please change the name of this function. Okay. It's not labse anymore. It can be attention as well. I've not had time to do it. We just change it to the replacement alignments or something like that. So you should have it somewhere. Yeah, sorry. Oh, we have two functions only. Cool, no problem. Then no problem. One function is for labse and another function is for attention, right? Whichever is enabled is used. So I think you know how attention works, right? So when you use send a source and you get the translation back, along with translation, you could also attention, right? Every token or every phrase in a given sentence has an attention, as in like in what context should it be translated. So attention is one of the parameters of your translation. So you can get that also as an output when you translate a sentence. Okay. So in attention, we can clearly, it becomes very easy for us to find out, okay, so this phrase is matching this phrase. This phrase is matching this phrase with respect to the similarity and all of that. So it's already implemented in NMT. So I just don't want to get too deep into it. But yeah, so this is the attention based alignment. That is the labse based alignment. TMX data is nothing but your search API. Okay. So here basically, if all user key is true, it means return all versions of all the phrases. If it is false, then only return the original phrase of the user that was entered. So same filtering logic. Okay. Filter lambda, I think so. This is the filter logic, which filters based on your org ID, user ID. Basically, when you search from the database, so basically what happens is in Redis, you can either do a search on a substring of a key, or you have to search all keys, or you can search on a given key. But here we can't do that, right? Now, when someone sends me a user ID, how will I know to which user should I search? Because the key in Redis is a hash. So it does not correspond to any user ID or org ID. So best option is to search the entire store and then filter based on the org ID user ID, because the value has org ID user ID. Redis is a key value store. You can't search on value. You can only search on key. Either you search on one key or a substring of the key or all keys. So here we search on all keys and then filter them using a lambda function to make it faster. Okay, and then original keys, all of that. Then this is the hash key. Basically, this function actually generates hashes for every record. You send a TMX record, it generates the hash and sends it back. Hash key search creates a MD5 hash values is user ID, org ID, context, local source. Yeah, basically it's a hash. When you are searching for a hash key, right? So you need a hash. So you need a key and then it creates a MD5 hash using the parameters that you have passed. And the same thing is returned. Suggestion box create is the suggestion box API. Update is the update API. Delete is the suggestion box delete API. And then this is the search API for suggestion box. Got it? These are the TMX API. These are the TMX.
Only one query. Why do we need hash key search function within this?
Hash key search as in like you need to search on hash key, right? That's what it does. Okay, so
that is the function that will be called repeatedly.
Yep. Okay, so when I want to search for a TMX, I need to know what to search, right? Let's say I am translating. And for this user, org level is enabled and user level both are enabled, which means every time I search a phrase, I should search at two levels. This is what that does. Get hash key search gives you the hashes available for the current translation that is happening. Clear? And then you have utilities, okay, like calling an API, downloading a file, topics from a given model, because we need to know, right? This guy, this NMT consumer, this guy should be reading from all the topics that are available, right? If there are now 100 models live in our Anuvaad ecosystem, doesn't matter how many are active in it. NMT should be able to read all, or basically NMT should be listening to all those active models. Otherwise, what is the point? Because NMT, you can't selectively say that, okay, this user is translating via this, so let me start listening to this topic. You can't do that. When the consumer starts, that is when you should give all the topics that it should listen to. So that is when we read the models initially, get all the topics, and then the consumer reads from them. This is RBAC, role-based TMX and UTM, right? So it says whether for a given role or a given org, whether TMX is enabled, UTM is enabled, all that. And this is another utility function, multiple strings in a sentence. Of course, then you have your validator to check whether this or that and stuff like that exists or not. And you have utilities, TMX, service, repository, Kafka. Configurations. Okay, these are the configurations. Kafka, Mongo, Redis. Clear till here? I'm sure you'll know. This is the TMX Redis. File download URL, because I need to download file, right? Whichever tokenizer I upload. Save content URL, because I need to make a call to content handler to save my block and sentence translations. Fetch content URL for me to fetch the content. Update content is when I want to, when I have done a block translation and I want to update the, Sentence fetch is when I want to do a fetch of the sentences, right? Because that is stored hypothesis, T3, T4.
Yes.
For that. User translation URL, whatever the user has stored, that is your UTM. NMT fetch models, because I need to read all the models before my consumer starts. Translate URL for translation, IT URL for interactive translation, labs align for labs alignment, attention align for attention alignment. Then what is the tool? Because tool is one of the parameters of our workflow code. It's a part of that workflow object that we generate. Download folder from where I can download my file from the shared storage. Default context for now is judiciary. You can change it anytime while translation. Just kind of try to enhance that contextual use case. Batch size for NMT, TMX word length. I remember in glossary, Katie had explained that we limited the size of the TMX phrase because we wanted to reduce the number of computations, right? So that is the reason. Number of maximum processes, as in number of parallel processes in the system, because every translation is a background process. So we don't want to swarm the system. So yeah. Then whether TMX is enabled, global level, org level, user level, whether it is enabled, disabled, you can switch it on and off. User translation enabled, whether it UTM is enabled or not. Then orgs for NMT disabled. Got it? No NMT bunch of orgs. So here you can configure all of them. If tomorrow another org comes, you can just say, please don't translate whenever a translation on this org comes. Roles for which TMX is enabled, role for which UTM is enabled. Because if you apply TMX and UTM to annotator, then what is the point of annotation? Annotator is annotating the quality of your machine translation. So there is no point of doing TMX. Yeah. So TMX and UTM are disabled for annotator, whereas translation will happen. That is important. Suggestion statuses, suggestion box status, whether it is pending, approved, rejected. Is attention based alignment enabled? If it is enabled, you use attention API, otherwise, or you use the labs API. Topics for your NMT. Translator input, output, no NMT, and of course there is a consumer group. You need a consumer group all the time. Number of partitions and all of that. Don't worry much about these things because these are all environment level configurations. So yeah, doesn't matter. Then data store configuration, as in what DBs do we use? For translator DB is the DB name, content, pages, batch. All of these are stored into the database because what if a batch translates, where should I hold the batch, right? A batch is sent to an empty, a translation is received back, that batch has to go somewhere, right? So we create a batches DB, a database, a collection separately to maintain state. Because see, once I keep on putting batches into it, for me it becomes very easy to aggregate, right? I can aggregate it into pages, I can also aggregate it into doc. So it becomes very easy for me to process. Then TMX collection and suggestion box collection, DBs as usual. Then this is the context path, I believe. Yeah, context path. And these are some messages for log. Clear with translator? All clear? Yeah. So this is translator part 2. So now here we complete the translator KT. Okay. Enhancements in translator. Of course, I mean, there is a lot of area for improvement, of course. So for now, I think my suggestion would be, see, translator is a very complex system. Okay, it has a lot of, it does a lot of things. Okay, one more thing I forgot. That cron job I spoke about, right? I'll show that also.
For batch updations.
Where are cron jobs? Cron jobs will separate. It should come out, by the way. Okay. Jobs manager. It has two. See, translator jobs manager, workflow jobs manager. Workflow jobs manager is a cron job which actually moves all the stale jobs to failed state. You might have seen that, right? The job was interrupted by the workflow manager, or the job was force failed by workflow manager. All of that is done by this cron job. This cron job runs, and so it's a sweeper cron. Okay, so this is again one of the design components. So in such systems, in high available or asynchronous systems as such, you usually tend to write a cron, these sweeper cron jobs, as in these cron jobs, they sweep through. So you know what a sweeper is, right? Once an event is over, sweeps all the things. So this is what it does. It sweeps through all the jobs and sees whichever are completed, whichever are in progress. If we are in progress for more than 6 hours, they'll fail it, which means it does not have to be something went wrong, right? For in our as per design, we want to finish every job in workflow manager before 6 hours, no matter how big the file is. Okay, so if it is waiting for more than 6 hours, then there's something has gone wrong, so it fails. So this is a sweeper cron, because we don't want any jobs to be dangling in between, like in an in progress state for a long time. It should either be completed or failed. It should go and reach an endpoint, right? So that is the point. That is what jobs manager for workflow manager does. Translator jobs manager is the jobs manager cron, which actually does your CH. See, it goes, gets the entire pages, gets a list of which jobs are completed, which are in progress. If it is completed, checks whether it is already inserted into the table or not. If it is not inserted, it gets all the batches, aggregates to pages, gets the pages, creates an object, and then hits the content handler. This is the data sync. See, the data sync of a workflow is content handler. That's the end point.
So this repeats every
15 seconds, once in 15 seconds. 15 seconds or 30 seconds, some configuration. Okay. So yeah, this is what it does. Once the CH is successful, it also tells to workflow manager that translator has completed this job. Got it? So translator only does communication between NMT, TMX, UTM, all of that. The sweeping job, as in once all the batches are translated, aggregating them into pages, moving to content handler. Once the content handler is done, pushing it back to the workflow manager is done by this cron job. Clear? It's like separation of concerns. Very lightweight. I mean, I think hardly 2-3 files in every cron job. So this cron manager is a folder inside which we have checked in multiple cron jobs. Tomorrow you might want to add more here also. Yeah. JM cron interval seconds, 5 seconds. Sorry, not 15 seconds, it's 5 seconds. Got it? So this is your cron job, which does that, and these are other configurations of a normal translation system. Clear? What do you feel about translator?
Able to go through the flow of it, but we'll need to go through line by line to get a better understanding of it over time.
True. I mean that of course you will need to get it.
To run locally, currently we don't have any NMT models. Can we use a new model like Google Translate will do that? We can call the third-party API and call the translator and see if the thing is working or not.
Provided that is already hosted on our NMT. See, you can't configure a model inside Translator. Models will be configured at NMT. So your GNMT first you configure it in the models, the NMT service. Translator will make an API call to NMT when it is starting up. At that time, if the model is available, surely you can hit. But if you are running in local, then the fetch model API should be pointing to the environment where you have hosted this new, I mean, like entered this new endpoint. So model. Otherwise, yeah, that should be it. Anumesh, are you able to hear what I'm saying?
Yes, yes.
He had an audio problem. Anyway, cool. Nusrat, are you there?
Yes, yes, Vishal.
Okay, fine. Okay, so this is translator. I'm just thinking if I'm
In the TMX part, we don't it's in generalized question. So here we are doing 5 versions of TMX reverse version. Coming to the glossary part for the DME, we are not doing that thing, right? Just pretty much straightforward.
Yeah, pretty much straightforward because that is what they want. Here the use case was different. Here, since it's judgments and legal documents, abbreviations, acronyms are always a problem, right? That's why we said we'll do it that way. But one thing, by the way, you asked for announcement, right? Please include stemming and lemmatization in translator.
It's translation.
Yeah, translator in translator.
Okay.
Sorry, translators in TMX. In TMX, please do lemmatization. Okay. Because Python already has a lemmatization support. So you don't have to rely on Elasticsearch like you do in glossary. Glossary just use a stemming library later on. But in translator, whenever you are storing into the TMX, that push to TMX store is there, no? In that function, add a lemmatization logic where you kind of lemmatize every phrase before you send. And while searching through your hopping window algorithm, there also please use a lemmatization algorithm where you kind of lemmatize the phrase and then you search. Right? That will solve this problem of caring, care, blessed, bless, all of that, right? So
that will work only for the English phrases.
Pretty much, yeah. Most are English phrases only. No one is including any other phrases. So like English phrases, the source is always English for most TMX.
So the thing is vice versa, vernacular and English. That
lemmatization won't work. Yeah, true. That you have to do a string match only. There is no other option. Provided, I don't know if there is another model out there which actually does that. But as far as I know it, there is no.
If we perform lemmatization while performing TMX and so on, there should be some sort of modification done to the target sentence or target.
True. Yeah, that is right.
Because that will create POS problems.
True.
While adding TMX also, the pronoun should be maintained, right? The same.
True. Yeah, target is a problem. If you lemmatize the source, then target, what should you do? Okay, let's think about it. I mean, this problem is same across both TMX and glossary. Okay, think through it. I'll also give it a thought and see if there's anything we can do. But yeah, that's a problem. But how does lemmatization solve POS problems? I think it is not. POS is part of speech. So yeah, there it is not in the context of translation. No, in a normal lemmatizer, translation is not a context. They just want to lemmatize and store.
Yes.
But since we are using it
with target languages, retriever will have some.
So we need a lemmatizer which is as accurate as it is for English for other Indic languages also. Only then we can use it.
Yes.
Okay, fine. So this is a problem statement. Okay, so we'll figure this problem out, solution out for this problem, and then implement. So at the end of the day, we have to implement it so as to remove redundancy from our TMX store and all of that. But yeah, it's a good problem to solve. Nusrat, you are you're not on mute. Okay, so cool. I think that is all. Anything else?
Let's take local and we'll start.
Yeah, I mean, you can deploy translator locally. So it can read configurations and everything from the file. So there is no remote configuration reading as such. Okay, coming to Zool part 2.